So this is a tough time slot. You got to choose between 12.8 DBA features, this one, which is DBA focused, and coding for network performance, which I think would have been interesting too. So I'm glad you guys ended up here. Because otherwise I would have been lonely. Yeah, so how many people have not been to a PUG before? So 1, 2, yeah. So you might not know who I am, what this joke is about. So I'll give you a background. And most people don't even know what this joke is about. So I worked at Progress, believe it or not, first job out of college. And that was back in 1989 in development. And I retired there in 2022, 2.5 years ago. So I had one job my entire career, which was working on the Progress database, which is now called the OpenEdge database. Gus Bjorklund was my mentor and my boss for many, many years. And then just through changes that happened, he ended up working for me for a couple of years when I had a services organization under me. So I worked in development for, I want to say 22 years, I think. And then I worked in services where I ran a managed database group for 10. And for 2 of those 10, Gus worked for me. And then Gus retired. So Gus came back and did these presentations, and he said he was from the Parmington Foundation. So when I retired, I said, Gus, I want to work for you in the Parmington Foundation. There's no real company here. There's no pay. But I think it's where, I'm going to say it's where the DBAs go to retire. So in the US, there's a TV show called The Office. And there's a guy named Dwight that wanted to be assistant manager. And the manager would say, you're not going to be assistant manager. You're going to be assistant to the manager. Or assistant to the manager. So this is the joke that I'm not the assistant groundskeeper because Gus is the head groundskeeper. I'm the assistant to the groundskeeper. I know this joke would do better in the US, I think, because it's a very popular show. So what am I here for? I'm going to talk about issues, and how many people are DBAs in the room or care about database stuff, right? This is why you're here. So we all run into interesting things that happen, and how do you overcome them? And there's been a ton of interesting things that happen. So this is a select few that I thought were interesting that maybe we can learn from. So things that me and my team have encountered over the years, and just talking to it. It's going to be interactive, because I'm not going to give you guys the answers. I'm going to give you a chance to give me the answer, okay? And I did this presentation back in 2012, so it's been 12 years since it's been done, so it is a retread, so some of the stuff is kind of old, but it still applies. So here's a application partner, Agility. The application partner is DMSI. They are a lumber distributor application is what they do. And so they had a customer that had a large distribution center, and they had a power failure. And when they brought the machine back up, they tried to start the database, and they got this: Agility, prod DB, plat_11.d5, error 02. What's error 02 mean? Anybody know? File not found, okay? Prostruct list on it, unable to get file status for the same file. Prostruct list end, okay? Database was 80 gigabytes. Again, this is a little bit dated. 80 gigabytes is probably not large today, but 12 years ago it was significant. Last good backup was a week old. Don't know why, but that's the situation that happened. They weren't running after imaging. They were on Linux. I got involved because the people at DMSI were dealing with this, and they had tried everything they could, and the customer was now down for about 36 hours before they called me, because they didn't know what to do. What's my next slide say? There you go. We're now interactive. So you are now me. They've been down for 36 hours. You got an 80 gigabyte database. You have no backup that's current. You have no after imaging, and the Linux, and you're getting this error. What do you do?
So only the database backup was 1 week old, or also the system backup?
So the database backup was a week old. They don't have a system backup. It never came up. At 36 hours, they probably would have explored that avenue. So that one's gone.
So is the path not mounted, not found, or is it just deleted and gone?
It's deleted and gone. It's not that the file system was not there. There were other files on the file system that were there. This one just is gone.
So we have a week old database.
Got to restore the week-old database. We could do that, but that's not what they wanted to do. They wanted something different. Let me see if I should go into a different mode so I can see what's up. Okay, so here's the first thing you do. When you come into a situation like this, before you do anything, copy the database. Make a copy of it somewhere. Why? Because you might need to start over. And if you've done damage, because you're going to be trying to do damage or trying to fix things, you might need to start over. But you know what else doing a copy does? It gives you time. It buys you time. The time it takes to copy that thing over, it could take 10 minutes, 15 minutes. At least it gives you time to think. So now you're like, okay, I'm doing something. So management's all on breathing down your neck. No, I'm doing something. So this is my first step, and let that step happen, and while you're thinking about what your next step is, so that way you don't make some rash decision. Use ProStrect list to determine what files were missing. We were lucky in this case because the file that was missing was part of an index area. Is that what it says? Yes, part of an index area. So what tools do you have available to you? ProStrect Unlock. Does anybody know what ProStrect Unlock does? Anybody ever use ProStrect Unlock? So ProStrect Unlock does two things. It does two things, and the two things it does is really bad. Both of them are really bad things. One thing it does is all the files associated with the database have a header in it, and all the headers have a timestamp. And when the database is open, it validates that all the timestamps match. Because if they don't match, somebody might have copied a file from another directory or restored a file on top of that file, and now you have a database that's mismatched because you have a database that was, this week, and you had you can imagine the case. I restored the backup to a different location. I'm copying that extent into this one. Well, it's not really a database anymore. It's got 99% of it is the database, and 1% is something that's a week old. So we have this protection in place that checks the timestamps of all the extents in the extent header, and if one doesn't match, it says we're not going to be able to open this because something's wrong. ProStrect Unlock will fix all the extent headers. So it'll fix all the timestamps in the extent header, so now you can get into the database. So now you can get into this database that does or does not exist. Another thing it does is it has an option to recreate an extent. So we're missing this extent. ProStrect Unlock would not only fix the timestamp if you've restored an older version of that extent, it can recreate this extent. It's not going to recreate the data that's in the extent, but it's going to recreate the extent. So you'll end up having an empty extent. What's that? So the structure will be good. So now you have, in this case, the database is now intact with an index area that is all empty. So what could you do? Rebuild the index. This would be the next step. What does ProStrect Build DB do? Does anybody know what that one is? Anybody ever use that one? ProStrect Build DB, if you can get a ST file, you can do a ProStrect Build DB, and it'll recreate the .db file from the structure file. So what does that do for you? So what you do is delete the .db file, say ProStrect database name and .st file, and it would rebuild that .db file. So now you have another intact database. Why would you do that? Well, what's in the .db file? The only thing in the .db file is the extent list. That's it. It has the timestamps for all the extent headers and the extent list. So there's really not much of importance in the .db file. So it can be rebuilt, and it can be rebuilt, and you'll have no harm. Try it. Go create yourself a demo database or sports or whatever you guys use, and pro into it. Do whatever you want. quit, remove the .db file and prostruct build db, and you'll see the DB file will be there in Pro and get back into it. It's a useful tool. You guys should have some experience using it. So we restored from the week old, and we did prostruct unlock. So now we have this odd extent that's fitting into this database that doesn't match, but it only held indexes, so we're going to rebuild all the indexes. But index rebuild failed, okay? And it failed due to finding bad blocks in the storage area. I mentioned this yesterday. I don't know if people were in my session yesterday. We're talking about what you can do that's recoverable and what you can do that's not recoverable. And this is, I think, another good thing to understand. If the utility you're running can run with after imaging turned on, that means it's recoverable. Index rebuild, you have to turn off after imaging in order to run index rebuild. Hence, in the event that you have a failure in index rebuild, there's no recovery for it. The only thing you can do is try it again or delete the database and start over. So given the fact that we were running into a problem where we found bad blocks in the storage area when it was reading, you think if I tried index rebuild again, you think it's going to get better?
Maybe truncate area.
Say that again?
Maybe truncate area.
Well, so you could truncate area, right? But the bad blocks that it was finding were not in the index block, because the way index rebuild works, the first thing it does for the indexes that it's getting rid of, it gets rid of that whole entire B tree. So the errors that it was having was in the storage area where records were stored. So if I truncated the area that had this, I'm going to lose all the data. I'm going to lose table data. So truncating the index area is really not going to help, because the errors I was having was in the record area, not in the index area. Are you saying? I can't hear you. You got to speak louder.
He doesn't know what the back blocks.
Oh, you don't know what the bad blocks are. What do bad blocks mean? So when it was reading, it got an error called 1124. Each block has a header in it, and in the header has the physical location of where that block is. And so when we read a block, we say, I'm reading a block that should be physical location 1, 2, 3, 4. We read the block, and the block says this physical location of this block is 5, 6, 7, 8, and we go, that block's in the wrong place. So it was a bad block. So or it had corruption in it, so it read something totally different, and it didn't have the correct header in it.
It's bad, not back.
Oh, bad. Yeah, it's bad. That should say bad blocks. Okay, sorry about that. That's my fault. Okay, so now that we know it's a bad block and not a back block, now what do you do? Anybody have thoughts? Who said that? What'd you say? DB repair. Okay, so there's another utility called DB repair. So we had to copy our original database over, because we can't do anything on this. Once you have an index rebuild that starts, that index rebuild either needs to complete, or you have to copy the database back. You have to start over. So we had the database that we copied. So we cannot now start over because we did damage. So we made things worse, not better. So we copied that back, added the missing extent. So now we're getting back to, we had a successful step 1. We didn't have a successful step 2. So let's get back to our successful step 1. And now we're going to truncate the BI file, do a DB repair scan, and choose the fix bad blocks, fix bad records. Okay? So now that we did that, now we have missing data. There's no doubt about this, because we removed some bad blocks that held records. Now, we may have index entries on indexes that point to those. So now you have indexes that are pointing to a block that's now zeroed. Worse, you might have a record that spanned multiple blocks because the record expanded. So the head of the record is in block 1. The middle or tail of that record is in block 2, and block 2 was just cleaned out. It turned into a free block because of the scan. So we need to do a dump and load. So we tried doing a binary dump and load, and it errored because it ran into a record that had a record fragment that it couldn't find, and it just stopped because at that point it's like, I don't know what to do. So we needed to do an ASCII dump and load to dump around some of the bad records. So we are able to do an ASCII dump, get as far as we could. I think the next slide says that. Oh, maybe not. So we did an ASCII dump, dumped from the top down till we got corruption, and then we did a ASCII dump descending on the priming index, descending. So we dumped from the bottom up, and there's probably a gap of data that could have been in between it, but there's nothing we could do. Well, yes. So then I was just going to say that. So then the next thing you could do is you could just know what the biggest row ID DB key is in row ID and do find by row ID, but that's going to take a long time. So anyways, we got them back. They lost some data, but at least the database was back up. They were down for 36 hours by the time they got to me. This took a couple hours to work this out. And what do we learn here? That the database was important, but they weren't treating it like it was important. They need to treat it better by doing daily backups, after imaging, and a good DR plan. Good? Success on this one? Interesting? Okay. Next steps, implement a good DR plan, which includes frequent backups, after imaging, test it annually. How many people test their disaster recovery plan? Every year? Okay. And it needs to be on paper. Think about this. Your DR plan needs to be on paper, because if it's on the computer and you lose your entire site because there's a power failure or something and you can't get your computer up, then how do you know how to execute your DR plan? And I have to tell you, when you're under the gun and it's an emergency, things that are so obvious to you, you forget. Okay, you ready for the next one? The case of the micromanager. So a brand name U.S. bank had SAN corruption. So this prevented crash recovery from completing. They had a hot standby database using OE replication, and this was years ago, so some of the stuff's going to be dated, but I think that there's a lot of value here. Okay, and this was a name brand bank. This is this is like a bank here. What's Santander? Is that a big bank in this area? This is a huge, like, top 5 bank in the U.S. They had a local backup and local AI files, but the backup would not restore. So something happened here, right? So they have SAN corruption. It corrupted the database such that they couldn't get to crash recovery, and it corrupted their on-disk backup at the same time. They had no previous backup. They were just backing up on top of their existing database. The replica database was up to date. So they had OE replication. They were on Windows, and the database size was 200 gigabytes. So what's the problem? The customer refused to fail over. While they have OE replication, they never ran their application on the failover environment. So they had no faith that they could ever even do it. And if they went over there, they were worried with the 200 gigabytes what it would take to fail back. Yeah. Replication was in sync. Okay. I don't think I have a what would you do in this one. So 200 gigabytes at the time where the DR machine was, the copy of that 200 gigabytes was not going to take hours. It was going to take days. It was just a long, long process. That's why they were worried about the failback. It was going to be tough. And here's the problem. This is right when I took over the managed database group. This happened really within the first month. And there's a team of DBAs, and the DBAs giving them options. We could copy that thing back, trying to figure out options, and they were getting more and more impatient, and they wanted a solution, and they wanted it now, no matter what. And the DBA said, well, we could force into the database. Anybody know what that means, forcing into the database? Anybody ever force into a database? Who's forced into a database? Good. You have some experience, right? What is forcing into the databases? Well, it used to be that you could just use -F on any command and it would force into the database. And I changed that way back when in version 8, I think. I said, no, you have to really care to do it. So you can only do it on truncate BI. So you're going to truncate the BI file, which forces you to go through crash recovery. But if you did -F on truncate BI, it's going to say you're forcing into the database, you're going to corrupt your database. Do you want to continue, yes or no? You say yes, and we will corrupt that database. So they offered force into the database. Do you guys know who this is? The pointy head boss from Dilbert? So Dilbert's a Office cartoon strip character. So the pointy head boss always makes the bad decision. So he heard, you mean I could force into the database and we'll be up in minutes? That's what he heard. So forcing into the database skips crash recovery. So they couldn't get through crash recovery. Everybody know what crash recovery is? I'm going to tell you anyways because I gotta make this interesting. So there are multiple phases to crash recovery. The first phase of crash recovery is go get the linked list of clusters that are physically on disk and fix that linked list. So you can go both forward and backwards through the BI file and make sure that those clusters are pointed to each other and everything's connected. That's phase 1. Phase 2 is go back, find the current cluster that you're in and go back to the previous cluster and start replaying notes, meaning I'm going to go take a note, find out what database block it references, find out the version of that block, and is the note version lower than that version? If it is, skip over it. If it's the same version, I'm going to apply that note to the database block and increase that version number by 1. And it says that brings all the database blocks up to date. That's called the redo phase of crash recovery. It's very similar to roll forward for after imaging. And then you have the undo phase of crash recovery where at that point, everything's up to date. Let's look at any open transactions. What open transactions are there? Let's undo those open transactions and back them out. So that's the 3 phases of crash recovery. We skipped it. So we don't know if the database blocks are up to date. We don't care if the cluster ring is intact because we got rid of it. We don't know if the database blocks are up to date or not, and we don't know if there are any open transactions and if they needed to be undone. So index rebuild does not fix this. A lot of times people think just index rebuild and life's going to be good. Well, that theory existed because way back when in the early days of progress, indexes get updated way more than records get updated. So when you forced into a database, the most likely place that you'd have problems would be in the index. So people just said, rebuild the indexes and you'll be fine. Well, that was kind of not true. But a lot of times it worked for them because that's where all the update activity was happening. Well, in modern days, I mean, updates, now that was back when you used to have 10 users on a database, back in version 5 and version 6. Now we get hundreds or thousands of users on the database. Everything's getting updated. So you can't just say, rebuild the indexes. That's going to fix the database. Dump and load won't fix the database. Dump and load certainly will make sure that all the records are intact, and then you index rebuild and all the records are intact. But what about those open transactions? They're not going to get undone. So this was a really bad option, but it did allow them to get back up and running with a database that might have integrity problems. So have confidence in your disaster recovery plan. They had OE replication. They had a plan. They just didn't know how to execute it. And be careful of the quick fix. Non-technical people will always choose the quick fix without knowing what the downstream ramifications of the quick fix would be. So that was bad. They survived it, but that's not the path that I would have suggested that they go.
So they started production on
They started production on a forced-in database.
no real of data.
It's 200 gigabytes. I mean, so there are some decision-making processes there. So this is a mortgage loan application, right? So what part got broken, or could they fix it themselves, knowing where they were in the loan process for some of these? They had to do some validations themselves to make sure that they knew what was going on. So we worked with them to do a failover test, and we made that an annual event. Okay. This one's interesting. This one, everybody's going to be, yes, you have a question.
Excuse me, but how did the story end? Did they succeed?
Yeah, they succeeded. They were up and they were up and running, and they, whatever the corruption they had, the open transactions they had, they worked that out. I never knew how they worked that out, but they were up and running and successful. And then they were on OpenEdge in this application for probably 4 more years after that, and then they transitioned off that application to something else. Not because of this event. I think that was just course of nature. So,
they could have data corruption later also. Without, I mean,
say that again.
they could have data corruption later. I don't lie.
Yes, they could have found these problems at end of quarter reporting. They could have found them at end of year reporting. And you have to hope that banking applications and mortgage applications, they have double checks, right? So hopefully they can paper trail and say, oh yeah, this must be from that event.
Isn't there also a risk that if you have a split record in 2 blocks, one is written to the database and one is in the memory, so
right.
Yeah, so you could have this risk also.
Right. So the point here is we're back to the record that is split, or part of the record was updated, the other part wasn't because it's split in multiple blocks, and a whole host of problems can happen here when you force in. I saw a lot of hands go up saying we forced into a database. I've done it a ton, but I know what the consequences are. I told tech support a long time ago, if any of your customers force into the database, I want to know about it. I want to know who they are and what the circumstances were. Because it was commonplace 20 years ago for tech support to just go force in. It'll all be good. And rebuild indexes, it'll turn off the damage flag, and you're on your way. And I said, you got to stop this. We were corrupting people's databases, so I want to know who they are, what the circumstances were. Okay, I scared enough people here. Good, go ahead.
But in that case, you had a good replicated database.
Yeah.
So they could have dumped the data there.
Yeah.
And compared with the dump they had from
Correct.
before.
Yes.
And then find out what were the missing bits or the open transactions, and then make decisions on whether or not to add that or not.
Exactly. So good, very good point. So there's another checks and balances with the replicated database. They could have done some archaeology there and figured that out, and they had to rebaseline that anyways, because once you force in, you got to replication. Everything's turned off at that point.
Would have in that case worked a typical rsync?
What's that?
An rsync?
This is on Windows, so that wasn't available to him. I'm glad we're talking. I'm glad we're interactive. Next one. This one's an interesting one. I think people here will have input on this one. I'm going to let you guys drive this one a little bit. So a large school district, it was in Texas. They needed to get report cards out, and they discovered they had corruption in their database. Backup stopped working for about a week. And what happened here? They had all the teachers, this was right at reporting period. So all the teachers put all the grades in on Thursday and Friday, and they found the corruption over the weekend. So they called me late. No, they found the corruption on Friday, because they called me on Friday night and said, "We need your help." And I didn't even know who these people were. I was like, "How'd you get my number? We'll work on that later, but you need my help, right?" 10.2b05, Windows 64. There, Windows. Who's running Windows? Sorry. You guys don't know about the Linux patch for that Intel machine? Last good backup was a week old. All the report card data for 30,000 students were entered since that backup. The district was going to lose face with their entire teacher population if those teachers had to re-input those grades for 30,000 students. So there was a lot of pressure from the administrators to say, we can't have the teachers do this. After imaging was turned on, but after image file retention was less than a week. So the last good backup was more than a week, and they have after image files, but they don't have after image files enough back to that week, and they had no offsite storage. Database is about 300 gig, and they have they restored the 1 week old backup to a different location. So now we have the current database that's corrupted, and we have a week old database that is not corrupted. What are you going to do? So you got the current database that has corruption. What did they say? What the corruption is? The backup stopped because it ran into a bad block. Okay, I should have said that. So they couldn't do a backup because it ran into a bad block. So they have physical corruption in the database. That's their production database sitting here. They have a week old restored database sitting here. What do you do?
You have to admit it.
Every student gets A+.
Yes, that's an option. Right? Every student wins.
The AI file is available.
The AI files are available, but there's no backup to go with them.
Depends on the database. I probably would have brought the 4G and tried to update. What's the difference?
Okay, so we're going to try to piecemeal the two pieces together. So let's go, right? We had two plans. We had to get corruption out of the live database. Maybe we got lucky. Maybe we could get lucky here, run DB repair, find out that the corruption was in an index-only area, and do the same thing that we did with that first database. That wasn't the case. We found out that we knew we didn't have to run DB repair to find that out. The corruption was in the record side, and we knew that because we're getting the errors in the log file. It tells us what storage area it is. We're looking, yep, that's not an index storage area. That's a record storage area. So now we're in trouble. Plan B: revert back to the old database. See if we can take the report card data from the live database and import it to the week-old database. So now they just go back in time a week. Maybe they'll end up losing attendance information, but at least all the report card stuff from the live database is now intact. So we have an intact database with the report card stuff. Those were the two plans. Let's go with plan A. The database log file showed us where the extents were. Each storage area was a single 80 gigabyte extent. Corruption was an 80 gigabyte extent. We're using DB repair to scan and fix bad blocks. This took hours to run on this extent. Again, this is about 10 years ago, so 80 gigs, it took hours to run. And it came upon the corruption, and the utility just crapped out, did nothing, because it had a bug in it. So that was a bummer. And at that point, we had one chance, because it took hours. We couldn't run it again because we knew it took hours. So we had to go to plan B. So we worked with the vendor to find all the tables that made up the report card processing, which was about 12 tables. So we dumped these from the live database, and there was good news is there was no corruption in those. So now we had to figure out how to load that into the old database, because you can't just load them in. They had to write programs to make sure that they had all the integrity in there, because it's not just loading data in there. They had to do it their way. So that was in their hands. It was out of mine. So we dumped the schema, and actually this was my idea to prevent them having to do this. I forgot about this. And so we dumped the schema for the 12 tables, and we went into the dictionary and we renamed those 12 tables to table_old. That's immediate. That's an easy thing to do. It doesn't do anything other than rename the table. So it's a one record update. And then we loaded the schema for the 12 tables. So now we have duplicate tables, one schema that's empty, no rows in it, and one that has the table name _old that has all the old rows. And we loaded the data for the 12 tables. So this was pretty useful. And they were concerned about recompiling the application. And you don't need to recompile the application in this case, because the table names were the same. So our code was able to work against this. Okay, so that was a pretty useful trick. Anybody would have thought of this? Going forward, you'll think of this, because this turned out to be useful. So now let's go back to plan A. Now that we have plan B, they were relaxed. Let's see what we can do to see if we can get that live database up. So there were 5 tables that had problems. So we did the 4GL dump, like I described before, I knew I had this in here somewhere. For each table by field export, for each table by field descending export. So that way we got both sides of it, from the top down till we hit corruption, then the bottom up till we hit corruption. But they didn't trust the data because they didn't know about the gap, and we didn't want to do the rec ID search because that takes a long time, right? So we used the same table rename technique to get these tables from the week-old backup. So these were not the reporting tables. These were the just other tables that had corruption, and they made the decision that those tables were not that important. They probably weren't updated. So let's get those tables from the week-old database and bring them into the live database. So upon further research, the problem was DB Repair would have fixed this if they weren't on 10.2b05. It was a bug in DB Repair on Windows in 10.2b05. Didn't know it at the time. So after we fixed the issue, we went and did some further analysis. They upgraded it to 10.2b08, and 10.2b08 was able to successfully DB Repair the database. We would have been in the same spot before, where we're now converting record blocks to empty blocks, so we still would have had to dump and load, so it still wouldn't have been a perfect situation. So what we ended up doing by combining the two databases together, it ended up being a better solution than going the DB Repair route.
Have been an option to first update the progress version and then do the DB repair?
And so the question was, would it have been an option to upgrade progress and then do the DB repair? Sure, if we knew DB repair was going to fail. But it took us 4 hours or something like that to find out that DB repair was going to fail. And then we had no guarantee that if we upgraded progress and did 4 hours more, that it wouldn't fail again. We didn't know that. So this is some hindsight. But this is an important one. If the extent size was smaller, it would have failed quicker. And if it failed quicker, we would have had more options. So a single file 80 gigabyte extent was rough. So my suggestion to everybody here, and I kind of did this yesterday, and we talked about it for a while in this room, is how big do you make your extents? And I argue you make your extents large enough that you can operate on them in a reasonable amount of time. On this machine, back at this time, 80 gigabytes, you couldn't operate on it in a reasonable amount of time. Even just to copy that file someplace else was taking hours. So the file was too big. They should have had 20 gigabyte extents and had 4 of them to make up that 80. Not single file storage areas. That's what they had, a single variable extent storage area. And that is just a recipe for disaster in the event that something happens like this. And if they stayed current, DB repair would have worked. So if they had smaller extents and were current, we would have solved this quicker. So that was the lesson learned there. And everybody got an A. Who said that? Okay, so a week later, they also had corruption in a different database. That was solved. We restored and rolled forward, and guess what? Roll forward didn't work. So we had to upgrade to 10.2b08 for the roll forward to work properly, and that's when we found out that we could go back to. So this is what forced them to upgrade, was the fact that roll forward didn't work. So I said, now they're on 10.2b08. Let's go. We still have that database. Let's go see if we could have DB repaired that database, and we could. So it wasn't that I came up with the idea of let's upgrade and see if DB repair. The upgrade was forced because of roll forward. So stay current. Next step, implement a DR solution, replication, roll forward, AI. We talked about replication. They didn't go for it, but at least we had a better plan for AI to have more than a week's worth of AI. They had plenty of disk space, so it was just silly that they didn't have enough AI. And this is another thing I suggest is, given that they had corruption twice within a week, was restore the backup on the same machine. You don't need another license. They had plenty of disk space. And then roll forward the AI files to the same machine. It's on the same machine. You're allowed to do that. It's on the same machine. And at least you're verifying your backups. You're verifying that roll forward works. It's going to help you in the event that you have problems. Because these guys had problems twice in a week. There was clearly something wrong with the machine. This is a way to protect against that. Okay. How am I doing on time? We got to get going. Performance problems. Case study 4, a large customer, 5,000 connected users, all of a sudden experience slowdowns. When it happens, the system escalates, so all screens are frozen. The operating system is AIX. You can log into AIX and you can do shell commands, but the application is just stopped. CPUs are not busy. System load is high, 60 to 80%. There's no single process spinning the CPU. This is what it looks like. This is a normal day. These are latch timeouts. Latch timeouts are when you run off a spin and you exhaust spin and we nap for a little bit. So this is a graph of napping. Look at the scale, 6, 8, 10, 12. So we're not napping much. When it's bad, look at the scale. So 6, 8, 10, 12, our scale is now 1,000. And when it started going bad, here, it just escalated. And then once it started going bad, it just continued going bad. So comparing the scales, 12 up there, 1,200 over there. So this just to tell you where, how things were. What do you do? Do I have a what do you do? Oh, so then I drove into latches. So specific latches. So we talked about, here's all the latches. Then we have the MTX was the one. If I'm over here, this would have been the MTX latch, right? So I went to more than the MTX. BHT, BIB, AIB were all getting affected. So they all started going up. So I'm trying to figure out what's going on here. Is it something on disk? What's causing this problem? The operating system seems reasonable from a shell standpoint, but the application is just really, when I say it's not running, screens were frozen for minutes. So what happened? It was not a disk space issue. It was not a network issue. These are great things to explore. Say that again?
Maybe you should ask your developer, has it provided an update for the software?
So you're saying upgrading OpenEdge or upgrading the operating system?
Upgrading the application.
Upgrading, did the application change? Application did not change. That's another great thing these are great questions to be asking, right? Go run the BI grow test and see, is the disk speed slower than it was before? No, that was good too.
As far as the storage is
Go ahead, back.
Some process holding a latch.
So, is there a process holding a lock? Yeah, there was, but they do give up. And so the latches are being held, but they're being released. It's just incredibly sluggish, which makes all the screens freeze because there's 5,000 users, right? So they're just not able to move. What's that?
Was the BI huge? Was there a BI problem?
There's not a BI problem. So it was not a disk problem. These are all great things that you guys are bringing up. But there's one huge elephant in the room that as soon as I say it, you guys are going to go, oh. AIX was configured to add CPUs when the workload got high. So they had a 32 CPU machine with only 16 CPUs allocated, and then the workload got high, and they added the 17th CPU. What do you think that did to that machine? Anybody know? NUMA. So now everything was on a single node, and all of a sudden they added one CPU because it triggered based on the configuration of AIX, and that spanned to a second NUMA node. And this is for people that don't know what NUMA is. This is what NUMA looks like. You have basically 4 different machines in this example with a high-speed interconnect, which sounds great on paper, doesn't work great for monolithic applications like databases. Why not? Here's what happened. So as soon as they added that 17th CPU, now you have processes that are now running on that 17th CPU. Those processes need to go attach to shared memory. The memory's on the other node, the 1 through 16 CPU. So now they're doing far memory reads against the memory on the other node, and that's what's called the NUMA quotient when they do a far memory read, which is usually 3 times slower than if you were reading locally. So you can imagine holding a latch. So you're on CPU 17 and you're spinning, all of a sudden it's your turn to get the latch. You hold that latch, and now you're going to go make a change to the LIU chain, right? So now you're going to move something from the LIU chain up, and it takes 3 times longer for you to do this. And while you're doing this, you're holding the latch, and all those guys on the other CPUs are just spinning like crazy trying to get that latch, and I'm taking 3 times longer holding that latch to get my job done, and then I release it. And the BIB latch, the AIB latch, those latches are held longer than like the LRU latch. So now that 3 times longer is really 3 times longer, and everybody's stacked up behind me. So all of a sudden latch timeouts go through the roof because it's the person that has the latch held is holding it for 3 times longer. So that's called far memory reads. And there's another piece here that wasn't really related, but I want to bring it up. This is called cache coherency. So when you have really big systems, really wide systems with many CPUs, we've got to get all those cache lines in line whenever you are testing to get a latch. So in order to do that, all the CPUs have to stop what they're doing and say, I need to know if you guys have this region of memory in your cache lines. All the CPUs stop and say, nope, I don't. And if somebody does, they said, well, you need to refresh it because I just made an update to it because I just changed the value from 0 to 1 to say that I have this region locked. So then anybody that has that piece of memory in the cache lines has to refresh it. It's called cache coherency to make sure that all the cache lines of all the CPUs are in line. So as you scale out CPUs, if you've got a 16 CPU machine, that's not bad. But if you've got a 64 CPU machine, this is going to be detrimental because we got to make sure that all 64 CPUs are synchronized, and these latches happen 1,000 times a second. This is not something that happens periodically. This is constant activity. So all of a sudden, your CPUs are really doing nothing but making sure that they are all synchronized, and they can't get any work done.
So is this also still a problem now?
Oh, yeah.
With VMs?
Oh, yeah. Yeah, so VMs isolate you from it because you can allocate specific CPU and memory to a VM. So from that VM, it looks like they're only working in that segmented environment. Just like this AIX machine. When it was on a single NUMA node with 16 CPUs, yeah, it had 32 CPUs allocated. They just weren't active at the time. And as soon as one get active, so in a VM, you're not seeing the whole world. You're only seeing a segment of the world. So NUMA is not bad for VMs, but NUMA is bad for a bare metal piece of hardware. So cache coherency, right? So how can you deal with this, right? So if this happens, everybody's going to have a NUMA machine. If you don't have a NUMA machine now, you're going to have a NUMA machine in the next 10 years. They're guaranteed. It's because it's just going to happen. Maybe not, because there's a battle going out. How many CPUs can you get, right? And NUMA helps you get really wide for CPUs. The other one is how many cores can you get on a socket. So you may be able to get a 32 CPU socket. That's great. So now you're going to end up having a cache coherency problem, but you're not going to have the NUMA far reaching problem. So you got to be careful about this. So the whole industry is either going NUMA to get wide, or they're doing cores on sockets to get wide. And so the fact that we've had multiple cores has helped us alleviate NUMA for a while, which is good. But if you end up in a NUMA environment, the way to deal with this is have less processes connected to shared memory. So do client server. Client server is going to help because the less processes connected to shared memory, the less contention that's going to happen between processes. Disable CPUs. That's going to help your cache coherency. You don't really, if you've got this really wide machine, but you're only 20% busy and 80% idle, well, you're not using it all. Start disabling CPUs so you get narrower and get that workload up to 60%, 70%. Or obviously buy a new machine. That's not NUMA. So the customer did do 2 and 3, so they reconfigured the machine so it couldn't go above 16. And then they migrated to Linux. And the Linux machine that they migrated, they went to AWS. The Linux machine they migrated to. On the AIX machine, they were pretty much 80 to 85% CPU bound on that machine. They went to the Linux machine in the cloud, and the CPUs was just so much faster that they never got more than 20% user time on the CPUs. Migrations and upgrades. What's this one? Oh, this one's easy. You guys should be able to figure this one out easy. So a large warehouse distribution center in Florida, 24/7 by 365. They have people picking off the racks, kind of like what Amazon would be doing all the time. This was for contact lenses. And they were not changing platforms. They were going from AIX to AIX, but they were upgrading their AIX environment. Database size is 500 gigabytes. It takes 6 hours to copy to the new machine. However, they blocked out a 2-hour window for the data migration. So that was a pretty big constraint when it took 6 hours to copy from one machine to another machine in the same data center. Do I have a what would you do here? Oh, what would you do? How would you do this?
Backup, restore, forward, and then just roll forward last.
There you go. This one's easy, right? So you back up the database, restore the database, and apply. So you migrate the application files, system files, and other files. We had to make a custom term info for these guys on the other machine because they were characters. They had green screen characters, and they had a custom term info. So we had to go back and to read the books on how to go do that because they hadn't done this for a long time. So we had to test it to make sure it all worked, and test some more. And then here's the special sauce as described. So use after imaging to keep the soon-to-be production database in sync. So you back up the database, you restore it to the other machine. It takes 6 hours to copy it over, restore it. Who cares how long it takes? Maybe it takes 3 days to get that whole thing going. And then you're applying AI files. So you're every 15 minutes, you're switching AI files, and you're applying them over. And then when it's cut over time, after you've tested everything, you're like, okay, just got to apply that last AI file, and boom, we're over there, and we met their 2-hour window easily. I have one more. Do you guys have time? Yeah, we have time. I've got one more here I kept. Case study 6. I wasn't sure if I was going to be able to get through all this. So this is the application partner. They do frequent updates of the database, but some of the customers run OE replication, and they're aware of this, but they don't know how to deal with OE replication. So the partner has, when they do updates, they know that there's a GR machine, so they do the application updates to the production machine, then they do the same application updates to the GR machine. That's their process. And they're on Windows. So the technical people don't do the updates. This is a very large partner, so they have a ton of customers, and they're all, for the most part, on-prem. And so they have a support staff team that just runs a script. And when I say run a script, it's not type the script. They have a script. Do this, shut down the database, run this command, do this, do this, do this. And so they know how to execute that script. And the script has to work for them, because if it doesn't work, they don't know what to do. So this is just support staff, mildly technical, but don't really know the application, certainly don't know OpenEdge. So when they do this, sometimes when they're upgrading the application, like any application upgrade, they need to also make schema changes. So they're upgrading the database as well. So do you guys see the problem here? So our process to help them was to get both environments set for them to go do this, because we knew that they were going down this path. So now they go and they do the update on production. They make the schema changes on production, and they don't know they're making schema changes. They're just running some procedure, and the procedure does what it's got to do. So then they go to DR, and they're making the application upgrade on DR, and they run the same thing, and it goes and connects to the database, starts the database up, and it performs crash recovery, because we had to, in order for them to do the update there, we had to turn off replication. So it performed crash recovery, and at that point, they're done. We can't apply AI files. We can't do anything else. So that's the scenario, right? So we need to rebaseline. Their database is large and it's overwhelmed, so rebaselining is a pain. So we're just trying to find a solution. These were a handful of our managed customers, and this would happen about every, I don't know, 3 months, 3 or 4 months. And so now we're like, okay, great. Now we got to go rebaseline these things again. We didn't want to do it. So what's our solution to this? How do we solve this problem? Nothing? You could think of a couple of things. One thing we could do, we tried, was roll forward op lock. Do you know what that is? Anybody know what that command is? Anybody ever use that command? This is probably the most underused command in progress. This forces the target database to only be able to accept AI files. I don't like it. I like it, but I don't like the way it was implemented. This was implemented after I left development. I like the op lock part, because now you're saying you can only take after image files. So it could take any other roll forwards that you want. And it'll just take them and take them and take them. And if you try to pro serve the database, try to pro the database, it says, no, you can't do it. This one is locked for roll forward only. When you do the roll forward op unlocked, the bummer is it unlocks it and then it goes to the crash recovery. So if you made the mistake and you unlocked it, you've now ruined it for any more roll forward. I wish they didn't do that. I wish they would just unlock it and say, okay, it's unlocked now. I can still roll forward. My danger period's over. But they made it so it goes to the crash recovery. So once you unlock it, that database is now meant to be used and can't be roll forwarded anymore. So this was one command that we did. And so why do we do this? This is going to prevent them from being able to use that database. So maybe the application upgrade would happen, right? But they wouldn't connect to the database and be able to use the database. And we did this, and what happened is their script no longer worked. So now that DR machine no longer, we had no idea if the upgrade to that application on the DR side actually worked or not. Just because it couldn't connect to the database, maybe the script didn't do the rest of what it had to do. So that wasn't really a good solution, but we tried that. So solution 2, this is a pretty obvious one. I was surprised you guys have been pretty interactive. We provided a second database that's a backup of the replica database on the DR machine. We used Pro Backup with no recovery to make sure the AI files could still be applied to this database. And then they could do whatever they wanted to the other database, because it's just a scratch. It's just a garbage database. Do whatever you want. When they're done, we just put our database back in place. So the support engineer was able to complete this. The database that they did it on was completely throwaway. We didn't care, because replication was going to bring over the schema changes anyways. So we didn't need them to do anything to that database. We didn't want them to do anything to the database, but they could. It was just completely throwaway. They did that. We threw the database away, put the backed up database in place, and then replication or roll forward, depending on the mechanism that we were using, was able to bring that database current with the application, because it was getting all that from production. There, so I had time for my last one. That one make sense? Yes? No? Okay. So these are some examples. I've done several of these talks. This is there are others of these. And so I went through years of iterations of these. One of these examples I updated, the performance one with Numa. I had 2. This one was a more recent example. But so, in the world, don't assume things can't go wrong, because they're going to go wrong. And, having a plan is not good enough. Testing the plan, having confidence. Remember that bank that wouldn't fail over. And if all else fails, seek professional help. I'm going to say it. I say it as a joke, tongue-in-cheek. You can't have me as your disaster recovery plan. Every one of these things that happened, I was involved. My team was involved, but even my team, when the pressure's on, they always called me in, because they just wanted to have another set of eyes. Because when the pressure's on, you don't remember it's roll forward, retry, or it's roll forward -A. What am I doing? Unless these things are something you use every single day, it can it can go away from you. So I was involved in every one of these and many, many, many other ones. So as I say, don't make Progress Tech Support a consulting company, I'm not working anymore, but me be your disaster recovery plan. Have a solid disaster recovery plan. Test it, have confidence. How many people have rolled forward? Okay, how many people have rolled forward last week? There's 1, 2 last week, right? The commands are not obvious, right? They're obvious to me. I have muscle memory for them because I had to type them in, more than 1 million times over my 30-year career, right? So they're muscle memory for me, but for you guys, just don't forget to just go through these steps, because when you're under the gun, you're gonna forget it. And if it becomes muscle memory, it's gonna be comfortable. So that's the presentation. I'm glad it was interactive. Do you guys have any questions?
About NUMA. So if you have one socket, you can also have the NUMA problem?
So let's talk about NUMA for a second. That's great, because I've talked about NUMA so much that I think people know what it is. Intel machines, by design, can only have 4 CPUs. That's it. That's all they can have. So if you need more than 4 CPUs, you need to do something. And so the way they did something is they strapped these machines together. So you could have an 8 CPU machine where you'd have 4 on this node, 4 on that node. And then you have this high-speed interconnect between them and 1 operating system around it. So that's a NUMA machine that allows you to have 8 CPUs. Well, now we have multi-core machines. So now you get this 4 CPU machine that you're allowed to have in a single unit. Well, you can have 2 cores. So that gives you your 8 CPUs. Or you could have 8 cores times 4 is 32 CPUs, all in that single machine. The cores are getting even more, that you might only have 2 cores, 2 sockets in that machine, 2 8 cores, to give you 16 CPUs. So that still keeps you less than the 4 that you're restricted to. You're restricted to 4 sockets. And the word CPU and core gets confused a lot. So in my nomenclature, I'm using CPU as a socket. So you're allowed to have 4 sockets or 4 CPUs on an Intel machine, and that's all you're ever allowed to have. But those CPUs or sockets can have multiple cores. So if you have a multi-core socket, it's not NUMA. The only time you're going to end up hitting NUMA is if you have more than 4 sockets. So if you've got 2 core sockets and you have 4 of them, that's going to give you 8. And if you have 4 more on another node, and they're 2 as well, that's going to give you 8 there. That gives you 16 CPUs, but you're NUMA because you have 8 sockets. So Intel only allows you to have 4 sockets in a system. That's it. That's all you're allowed to have. You can have as many cores as you want on a socket. So if you have many cores and only 2 sockets, you're not NUMA. Does that make sense? Everybody understood that? Okay. Any other questions? Did you find this useful? I liked how interactive it was. Did you find this useful? Because I'm trying to figure out what to do. I mean, I've been presenting these things. I've been presenting this stuff for decades, and I'm kind of running out of material.
When you've been so long in the disaster recovery, which operation systems you had the most trouble with?
Well, how many of mine over here were Windows, right? And the reason why Windows has so many problems is because Windows supports so many devices, right? So they support, every device on the planet they support. And so all those devices need device drivers. So these device companies go and they farm out the device driver work to somebody to get it to work. And some of the device drivers are great, and some of the device drivers aren't great. So Windows can be a great system, or Windows cannot be a great system, depending on what hardware you have under Windows and what the device driver is for that hardware. That's the Windows problem. Linux doesn't have that problem because they don't support every single hard drive that's out there. Their support's more limited, so the number of device drivers that they have is much more limited. So yeah, you can still have a bad device driver, but it's limited, and you kind of hear stuff. So Linux has been a better supported platform than Windows, and it's not because of the operating system, even though I really like programming in the shell, and Windows has some its own nuances about how to operate on Windows, but it's about the device driver support that causes the Windows problems. In my experience, I'm not trying to convince anybody to do anything different. I'm just giving you my experience. When we have problems, the problems tend to be on the Windows platforms. Linux is very stable now. AIX is going away, and that's really just came down to those two platforms. We don't really see anything else anymore. Any other questions?
The Furgal test is bad. Can that be NUMA related?
If the Furgal test, and that's my test, and I didn't name it, by the way, Tom or I think Paul Kafalis named it. If it's bad, does that mean it's NUMA? Is that your question? No. NUMA and disk drives have nothing to do with each other. So the Furgal test is just testing the speed of the disk. That's all it's doing. So on a NUMA machine, not a NUMA machine, it's not going to have any impact at all. Okay, and that's if you have a slow result from that, you got to look at your configuration of the SAN. If you're on a VM, you know, there's getting more and more layers between the operating system and the physical disk, and there could be problems anywhere there, right? So that's where you have to kind of work is from the operating system down. And there's another on Linux. There's another way to mimic the test, the BIGRO test. You can do DD in file something. Like to get a big BI file and the out file to another file and do osync equals or sync equals desync, and that will do the same thing as what BIGRO does. And when you're fighting with vendors, they're going to say, "What's this test you're doing? That test is the problem." You can say, "No, I'm just doing DD," and it'll reproduce the exact same thing. And that way you can say, "Vendor, get this to go fast." And if they can get that to go fast, then everything else will go fast. Yeah. Anything else? This is my last session. Anything else? I'll be around, but this is my last chance to talk. Okay. Thanks, everyone.